Good afternoon to all. So this is Kumar from SMS College of Technology and Department of Computer Engineering. So now I'm telling about the real-time CPU scheduling algorithm. So what is real-time CPU scheduling? In real-time CPU scheduling, we have two categories. One is a soft real-time system and a hard real-time system. So soft real-time system means provide no guarantees as to when a critical real-time process will be scheduled. So they guaranteed only that the process will be given preference over non-critical processes. So hard real-time system, so it have a stricter requirements. A task must be serviced by its deadline. So service after the deadline as expired is the same as no service to all. So minimizing latency. So event latency is the amount of time that elapses from when an event occurs to when it is serviced. So here in this figure, so we have event latencies and the real-time system response to E. So event latency stands to T0 to T1. So two types of latencies affect the performance of real-time systems. So one is interrupt latency, second one is dispatch latency. So interrupt latency refers to the period of time from the arrival of an interrupt at the CPU to the start of the routine that services the interrupt. So the amount of time required for the scheduling dispatcher to stop the process and start another is known as dispatch latencies. When an interrupt occurs, the operating system must first complete the instruction it is executing and determine the type of interrupt so that occurred. So it must then save the state of the current process before servicing the interrupt using the specific interrupt. That service routine, the total time required to perform these tasks is to interrupt latencies. So in interrupt latency in this diagram, the task T running interrupt and determine interrupt type and the context switch and interrupt latencies and ISR. And we have dispatch latencies like event and dispatch latencies and real-time process execution and response interval and process made available and interrupt processing. So the most effective technique for keeping dispatch latencies low is to provide preemptive kernels. So the conflict phase of dispatch latencies has two components. So preemption of any process running in the kernel, so released by low priority processes of resources needed by high priority processes. So priority based scheduling, so that the process are considered a periodic, the rate of a periodic task is 1 and by P. So we have a three type of process and three type of data is available. So we have a periodic 1 and periodic 2 and periodic 3 with the time slides. Then using a technique known as an admission control algorithm, the scheduler does two things. It either admits the process guaranteeing that the process will complete on time or rejects the request as impossible if it cannot guarantee so that the task will be serviced by its deadline. So scheduling of task when P2 has a higher priority than P1. So rate monitoring scheduling. So the rate monitoring scheduling algorithm schedules a periodic task using a static priority policy with preemption. So if a lower priority process is running and a higher priority process becomes available to run, it will preempt the lower priority process. So upmonitoring the system, each periodic task is assigned as a priority inversely based on its period. So the shorter the period, that higher the priority, the longer the period, the lower the priority. The rationale behind this policy is to assign a higher priority to tasks that require the CPU more often. So we have a rate monitoring scheduling and then missing deadlines with rate monitoring scheduling two diagrams. So in the top diagram, so we have deadlines with P1 to P1 P2 with a different type of time slicing. With the second bottom of the diagram, we have a P1 P2 and P1 P2 deadlines of the process. So earliest deadline first scheduling algorithm. So earliest deadline first scheduling dynamically assigns priorities according to deadline. So the earlier the deadline, the higher the priority. So the later the deadline, the lower the priority. Professional share scheduling. So in a professional share scheduler, so operates by allocating T share among the all participants. And applications can receive n shares of time, thus ensure that the application will have n and t of the total processor time. Physical real-time scheduling. The physical real-time standard also provide extensions for all real-time computing, and here we cover some of the POSIX API related to scheduling real-time threads. And POSIX defines two scheduling classes for real-time threads. The POSIX of API specify the following two functions of for the setting the scheduling policy, and pthread ATR gets scheduled policy, pthread ATR end policy, and pthread ATR set scheduled policy, and pthread ATR end policy. Thank you.